The video EBC1 EBC Basics, we discuss what is event-based capture, some EBC requirements, and that EBC rules are basically Suricata rules. Now let's take a look at some Suricata rules. Suricata rules can be complex, but the basic format consists of just three parts. The action, which determines what happens when the signature matches. The header, which defines the protocol, the source IP and port, the destination IP and port, and the direction. The direction tells which way the signature has to match, and nearly every signature has an arrow to the right. This means that only packets with the same direction can match. However, it's possible to have a rule that matches in both directions. There is no reverse direction though, so you want to make sure that you have the source IP and port first. The rule options define the specifics of the rule. Options allow you to specify granular matching parameters. You can even use Perl-compatible regular expressions. Make note that the metadata EBC PCAP option is what makes the PX save the entire flow separately in the directory structure. This option is specific to our EBC rules. You wouldn't use it with other Suricata signatures. And keep in mind that EBC processes only flow-based alerts, so ICMP and other traffic is not supported in our EBC rules. Look at the alerts in IA. We can scroll down and search to see the specific EBC alert that was triggered. Notice the alert description shows up in the interface here. Now we can reconstruct the flow that generated this alert and follow the stream to see the client and server communication. If we use the encode-decode tool to decode this URL, we see that the string our EBC rule was looking for exists. Now here's the rule that created that alert we looked at. Notice the action is alert because we aren't using IPS functionality here. The protocol is HTTP, and we're looking for any source IP address and port or destination IP address and port in the header. The options portion starts with the message to be displayed when the rule triggers. Next is the flow keyword, which has many options, but we're looking for the flow to be established to the server as opposed to the client. Content is a payload keyword. It allows you to indicate what you want to match. And here we have two content statements looking for the words into and out file. The no case keyword makes the match case insensitive. HTTP_URI is a content modifier keyword that says inspect the HTTP URI buffer for content. PCRE matches specific regular expressions. As you probably know, regular expression searches can affect performance, so to mitigate the impact, PCRE is mostly combined with the content keyword. This way, content has to match before PCRE will be checked. In the above example, into and out file must match before the regular expression will be checked. The dot is part of the regular expression. It matches on every byte except for new line characters. Plus matches on one or more occurrences of the previous expression. U makes the regular expression match on the normalized URI, and I makes the regular expression match case insensitive. Then regex is used to look for the string into out file. Next, we have metadata EBC, which makes PX save the entire flow for a configurable time period. And finally, the unique signature ID. There are many resources for Suricata signatures that you can modify for use as event-based capture rules in your Trellix network forensics solution.